This is a video introduction to your first laboratory experiment. This video is meant to help you understand what your tasks are during this week's lab. The focus on this week's lab is on taking measurements using the correct number of significant figures. For the most part, this means that you are going to practice recording measurements to the correct decimal place. Taking measurements using the correct decimal place is easy using digital tools like the electronic balance. You simply just record all of the digits that you see. But when you're taking measurements using regular measuring tools like a graduated cylinder, you've got to take note of the major and minor scales on each piece of equipment that you use. Whenever you use a measuring tool like this, you should always estimate to the best of your ability between the lines of the minor scale. For example, this 10 milliliter graduated cylinder has a major scale of 1 milliliter and a minor scale of 0.1 milliliter. But you can estimate if the meniscus is exactly on the minor scale line or slightly between two of those lines. By estimating to the hundredths digit or reading between these lines, you can make your measurement more precise. It is understood that the last digit in your recorded measurement is estimated. Here's another example. This 100 milliliter graduated cylinder has a major scale of 10 milliliters and a minor scale of 1 milliliter. So you can estimate to the nearest tenths place. In other words, estimate between the lines and record your answer with 1 decimal place. In part A in this lab, you'll take a close look at 3 different graduated cylinders, and you'll determine how many digits you can record in each case. You should always estimate to 1 digit past the marked minor scale. In part B of this lab, you'll determine whether all measurements with different types of glassware give you the same volume reading for the same amount of water. You'll start with a 50 milliliter beaker and add water until the meniscus is exactly on the 10 milliliter mark. Then pour that water into the 10 milliliter graduated cylinder. Is it really 10 milliliters? Record the volume in your data table using the scale on the 10 milliliter cylinder. Then pour this water into the 25 milliliter beaker and record its volume on that scale. Then repeat by pouring the water into the 100 milliliter graduated cylinder and recording the volume using that scale. This experiment will show you that there is some variation in our measurements depending on the glassware that we use. It's not important that every time you get somewhere near 10 milliliters on your measurements. It's important that you record your data to the correct number of significant figures. In part C, you will use the density of water to determine which measuring tool is the most accurate. To experimentally determine the density of water, first, you'll weigh your dry measuring container on the electronic balance and record its mass. Then, add 10 milliliters to this container and weigh it again. Subtract these two values to get the mass of 10 milliliters of water according to that particular piece of glassware. If you compare the experimental density of your water, or the density that you measured, to the actual literature density of water, or the predicted value, you'll be able to determine your percent error and determine how accurate that piece of glassware is. After lab, please go back to the classroom and finish the post-lab questions. The post-lab questions include lots of extra practice doing dosing problems and using dimensional analysis. This will give you even more practice with dimensional analysis, and your instructor will be there to help guide you if needed. Make sure you ask for help with dimensional analysis if you are still confused about how to use the system or how to identify the types of information you need to use to do these problems.